So this is a exploratory talk. I hope to give a sense of sincerely grappling with some very difficult questions that no one really has the answers to. I think the advantage of giving that type of talk is that you can get my current thoughts live in real time on these issues. The disadvantage is I can't promise any satisfying resolution to any of the issues raised. I think that it's a difficult type of talk to give over Zoom, actually, because in a way, the function of such a talk is to set things up for a nice coffee break, and there is no coffee break. But my email address is on the first slide there, and if you do have any thoughts about this that come to you after the session, I'd love to hear via email. Maybe we can set up some kind of virtual coffee. If you want any of the slides to this talk, there's a link on the bottom of the slide that I've also just posted in the chat, bit.ly/birchnorm, that will bring up the same slides that are on the screen. So my topic is the evolution of reasons. I've been thinking about this. My starting point has largely been this book from 2006 called Rational Animals, edited by Susan Hurley and Matthew Nudds. I think it's a wonderfully rich book that lays down a whole load of threads, many of which have seemingly not been picked up since. Susan Hurley tragically died in 2007. I think to some extent, she's left a huge void that we still experience now, because I think had she lived, she would certainly have produced absolutely groundbreaking, era-defining work on this exact issue I'm talking about, and no one has managed to step into that gap. So the topic is rational action, or as I'm going to call it, reason-guided action, that I think is a better word because it's a less intellectualizing word. Think about playing chess. If you're anything like me, you're a beginner level chess player and you make a lot of bad moves, a lot of moves that don't really help you very much, but nonetheless, there's always a reason for every move. And if someone asked you, why did you do that? You could give an answer. You're trying to achieve a certain goal, trying to achieve checkmate. You've got a certain kind of plan about how that's going to be achieved. You thought that was a way to do it. Turns out it isn't. You can give reasons. And that ability to give reasons for what we do, I think, is a ubiquitous feature of our practical lives, not just something that happens when we're playing chess. So if I go to collect my son from nursery later, I know there's roadworks blocking one route into town, and I know there's some more roadworks blocking the other route into town. So I will take the third route. My action will be guided by a reason, by an instrumental reason. And I'm thinking about two questions. One is, how deep an evolutionary history does reason-guided action have? As humans go through life, we feel this internal pressure for our actions to make sense. When we're playing chess, when we're driving, in everything. How deep an evolutionary history does that internal pressure to make sense have? I will eventually in the talk put a conjecture on the table, which is that it may be a trait of all the amniotes, which is all the mammals, birds, reptiles. In a way, I'm putting that on the table in the hope of it being challenged in interesting ways. And the second question I'm thinking about is, how does the evolution of reason-guided action relate to consciousness or sentience, to subjective experience? That's a question that I really should have a view on, because I'm the PI of a project called the Foundations of Animal Sentience project that aims to study consciousness scientifically in animals and to develop new ways of doing that. I should have a view on how that relates to the evolution of reason-guided action, and I'm trying to work out what my view is. The conjecture that I'm eventually going to put on the table in this talk is that there's no reason-guided action without sentience, that sentience is, subjective experience is a precondition for reason-guided action. If that's right, then it suggests that it may have been a significant mistake for these research programs to be as separate as they have been up to now, and for norms and normativity and rationality and rational action to be studied as separately as they have been from consciousness, sentience, subjective experience. Perhaps those research programs should really be much more integrated than they are. So those are my two questions that, as I say, I'm not going to answer, but I'm going to put some conjectures out there. I think an important clarifying remark is about how I see the relationship between instrumental reasons and social norms. I think of social norms as capturing a specific type of reason, a reason to behave in a particular way because it is our way of behaving, and not simply because it's a means to a desired end. And I think that is a very specific type of reason-guided action, not the whole thing at all. And I suspect that specific type of reason-guided action to be uniquely hominin. I've argued for that in two papers last year that are on the slide there. And remember, the link to the slides is on the bottom. Partly that's those papers are very dependent on some recent work in archaeology by Kerry Shipton and collaborators, documenting very painstakingly the different styles of tool making that existed in the Acheulean about 500,000 years ago. And I've argued in those papers that on the one hand, we can see this as an archaeological signature of there being genuine social norms, people doing things a particular way because it's our way and not just because it's a way to achieve a desired end. But I also go further and argue that the pressures of trying to make these tools collaboratively created a selection pressure for the evolution of internalizing social norms, because members of a social group needed to be on the same page, so to speak, about what type of tool they were attempting to make together. But anyway, that's my argument from last year. Although I suspect this particular type of reason to be uniquely hominin, I also suspect it to be a relative latecomer in the evolutionary history of reason-guided action. I think reason-guided action probably has a much deeper history than social norms. I suspect in particular that instrumental reasons to do some action because it's a means to a desired end. I move the pawn because I'm trying to get you into checkmate. I go the long way around because I want to avoid the roadworks. I suspect these instrumental reasons have a more ancient history, and that's the idea I want to explore in this talk. You might think, well, hang on, are we going all the way back to the beginning of life now? Instrumental reasons there at the dawn of life. What about a bacterium doing a biased random walk along a nutrient gradient? They do random walks, but they're not completely random. When they're getting further away from the nutrient, they're more likely to turn than when they're getting closer. Is that instrumental reasons? Well, let's not get carried away here. I don't think it is. An evolutionary rationale can be given for the biased random walk. And in fact, evolutionary rationales can be given for all manner of biological processes. But these evolutionary rationales are not reasons for the organism. They're not reasons by the organism's own lights or from the organism's point of view. This is a point Dan Dennett has emphasized in his Bacteria to Bark and Back book. If you think about something like your red blood cells, there's evolutionary rationales even for what your own red blood cells do. They lack nuclei, for example, for a reason. Gives them more surface area for absorbing, transporting oxygen. A rationale can be given, but the red blood cell is not acting for those reasons. It is not feeling any internal pressure to act in a way that makes sense. These rationales that we might give for a red blood cell or a bacterium, they're what Dennett calls free-floating rationales. I think we can contrast free-floating rationales with what we might call anchored rationales. Whatever the opposite of that is. They're anchored, they are organisms that have a certain kind of normative force for the organism. They guide action, they have normative force of at least a basic kind for the organism itself. And that's because the organism itself represents those reasons in some form as reasons to perform some actions rather than others. Now, that's a really hard capacity to actually characterize, to really pin down what it is we're trying to explain. I think we must resist the temptation to trivialize it, as we would be doing if we said bacteria and red blood cells had it. At the same time, I think we need to resist the opposite temptation, the temptation to over-intellectualize, that I think philosophers and scientists have routinely drawn into, we need to, in a way, steer a course between a whirlpool and a rock. Right? We need to somehow steer a course between the whirlpool of trivializing reason-guided action and the rock of over-intellectualizing reason-guided action, and find somewhere, some course between those things. That's what a lot of the authors in that 2006 book, Rational Animals, are attempting to do. And it's what Susan Hurley is attempting to do in her paper, Making Sense of Animals. I like that paper a lot, and I'm going to put forward a Hurley-inspired starting point. The one idea I take from Susan Hurley's work on this is that we can come up with a mark of genuine reason-guided action, what I've called sort of anchored reasons, rather than free-floating. The proposal is that the mark of action-guiding reasons is the possibility of a certain kind of mistake. If there's a certain if animals can make a mistake of the right type, we can say that they're acting for reasons. The relevant type of mistake is what I'm going to call a whole agent, own lights practical mistake. And I'm going to now try and unpack what that type of mistake is. That this phrase own lights, what we're looking for is cases where the animal can get things wrong by its own lights, not just by the lights of a human observer judging it by appropriate standards. If a bacterium takes the wrong path on a nutrient gradient, goes the wrong way, you know, we can point and laugh and say, silly bacterium, we can judge it and we can say it's made a mistake. But there's no real sense in which it's made a mistake by its own lights. You can contrast that with a case where I make a poor chess move. It's not just a poor chess move by an external observer looking in, saying that was a bad move. It's bad relative to, it will often be a bad move relative to reasons that are my own reasons. You know, I understand the rules of chess. I have a particular goal. I know the information. I've thought it through. I realized I'd be putting my queen at risk if I, moved it over there. But then I just did it anyway. I just didn't think carefully enough. And I made a move that was a mistake by my own lights. So that's one important ingredient of what we're talking about. But there's also this idea of it being a whole agent mistake. This is what Hurley refers to as the holism condition, that we're talking about a situation in which the whole agent gets things wrong by its own light, not just its sensory or motor control subsystems. So again, think of me making a poor chess move, poor by my own lights, not just by the lights of some external observer, versus a situation where when I make a bad move, but I couldn't see the pieces, I've been momentarily blinded by the sun. It doesn't seem like a failure of practical reason on my part that I was momentarily blinded by the sun. That's interference with a perceptual subsystem. It's not me being irrational. If someone came in and said, that was irrational, they'd be harsh and they'd be wrong. Similarly, I'm not a particularly well-coordinated person. You could imagine a case in which I reach for a cup and try to grasp it and drop it. It seems like if someone came along and said, man, that was irrational, you've really not thought that through. I mean, you wanted to drink from the cup, so rationally, you really should have grasped it correctly. They'd be making a certain error in that the kind of mistake I made there was not a mistake of practical reasoning. It was a failure of a motor control subsystem. I reasoned correctly that I should grab the cup, but I just failed to do it because of a failure of motor control. So we're looking for something in virtue of which it can be the whole agent getting things wrong by its own lights, not just its sensory or motor control subsystems. So these I think of as anti-trivializing moves. We're trying to characterize this capacity of reason-guided action. We've identified the risks of trivializing and over-intellectualizing. If we trivialize, we end up saying bacteria have it. and that seems incorrect. Our attempt to resist trivialization is to say there's got to be the possibility of a certain kind of mistake, a whole agent own light's practical mistake. There's a certain kind of over-dramatic response to these anti-trivializing moves, which is to say, well, in that case, you're talking about intellectual capacity, that if you want to get whole agent own light's mistakes, then we're talking here about explicit conceptual practical reasoning with Aristotle-style practical syllogisms and propositional attitudes and things like that. There has to be a process of moving between propositions that can go wrong by failing to conform to norms of good practical reasoning that the agent grasps and endorses. If that was right, then we'd have some reason to think that responding to practical reasons would turn out to be a distinctively hominin trait after all. But I think that's not right. I think it's a much too dramatic response to resisting the whirlpool of trivialization, one that sends us straight back into the rock of over-intellectualizing. Because if we think about explicit conceptual practical reasoning, how often does it even happen in humans? Does it really guide my driving when I choose a route to pick up my son from nursery? Does it really even guide my chess playing? Well, I think for me it does, because I'm a beginner. I think I do explicitly think through the moves that I'm going to make. But I think there's significant evidence that experts generally don't play that way. For experts, chess is a much more intuitive game, as depicted in the Netflix show The Queen's Gambit, for example. It is not about thinking through explicitly the consequences of every possible move, but about seeing patterns. So I think if we go down that route, we end up with the conclusion that responding to practical reasons is something we rarely do, and that is not just uniquely hominin, but rarely used by hominins, and that seems very bad. So here's a popular alternative response to rejecting trivializing, one that I associate with Bennett Hurley, but also Ruth Millikan, Joël Proust, Peter Railton, Elizabeth Camp, and her co-author Ellie Shoup, all in different ways have developed the thought that for reason-guided action of a non-trivial kind, a capacity for simulation may be enough. And I'm going to call that the simulation approach, because I think it's a big influential approach that we see developed in different ways, at least 6 different times by these different authors. The general thought is that an animal doesn't need to have explicit conceptual reasoning abilities to have a capacity for simulation of options. And simulation of different options can guide decision in ways that respond to contingencies between environmental features. Simulation enables what Tolman in his work on rats called vicarious trial and error, or trial and error in the head. It's Millikan's rather more folksy phrase. And when you've got that trial and error in the head going on, you have a certain kind of responsiveness to reasons. And the thought would be that you have the possibility of the right kind of mistake. You have the possibility of whole animal own light's mistakes. Because if this animal is simulating possible options, there's a way of going wrong that is not just a failure of sensory systems or a failure of motor subsystems, but rather the animal can get things wrong by failing to select the option that was recommended by its own simulations. And that's quite plausibly what happens a lot of the time when people make bad chess moves. You know, they had reasons. They had reasons for making a different move, but they didn't stop and think carefully enough, didn't run enough simulations, chose the wrong option. And then the thought would be that that's an error of practical reason. You can call that an error of practical reason with or without any explicit conceptual reasoning going on. Simulation is enough. And conversely, when the animal succeeds, part of the explanation of why it succeeded is that it was guided by the reasons that were encoded in its inner simulations. So these are not just free-floating rationales, they're rationales that exist for the animal, that are internally represented by the animal, but they're not represented propositionally, they're represented in the form of simulations of possible actions. So I think that's a very plausible line of thought, which is why so many people have endorsed something like it. I also think it's subject to a significant challenge, which is what I want to go on to now. The challenge is that maybe there's just too much simulation going on in the brain for simulation to be in any way a special kind of thing that grounds facts about reason-guided action. In particular, even very low-level motor control processes are typically thought to involve an element of simulation. See the literature on so-called internal models. Started in the late 90s and has become an incredibly popular approach to motor control, where if you think about a low-level motor action like grasping a cup, reaching up, grabbing a cup by the handle, picking it up off the shelf, a huge amount of modeling, a lot of it done, it's thought to be done by the cerebellum, kind of at the back of the head, is involved in getting that right. You have to apply exactly the right grip strength. You have to clench your fingers in just the right way. And then a typical account of how this is done is that it involves so-called inverse models, where the desired trajectory is calculated, and then there's a model that has to work out what sort of bodily movements are required to realize that trajectory in the circumstances, and what sort of grip strength and so on is actually going to be needed. And so there's a sense in which these models are a kind of simulation, and that if the handle of a cup slips through my grasp, this may be a failure of simulation guidance, that there's a model in the cerebellum that is guiding my action, it's got something wrong, the cup slipped through my grasp, smashed on the floor. But as we've already said, that doesn't seem to be enough to say there was a failure by me to respond to practical reasons. That doesn't seem like the kind of whole agent unlikes mistake we're talking about. It seems like exactly the sort of case that Hurley quite sensibly wanted to say was not a case of reason-guided action. So we've got a bit of a problem here. Just saying capacity for simulation is enough seems to take us back into the whirlpool. It seems like in our effort to avoid over-intellectualizing this capacity for reason-guided action, we've ended up trivializing it again and making it the kind of thing that very low-level motor processing in the cerebellum achieves. So how do we respond to that challenge? I think it's easy enough to see the general shape of a response to the challenge, which is to say, well, only simulation of the right level of sophistication allows an agent to respond to reasons. But of course, that's only an outline of a response, not a real response. You've got to say something about what type of simulation has the right level of sophistication. That, I think, is a huge challenge that we should pick up and try to meet. The hope is that we can give an account here of the right level of sophistication a simulation has to have to support reason-guided action in a way that doesn't force us to bring back in explicit practical reasoning, because then we've hit the rock again if that happens. So I'm going to consider now ingredients for such an account, ingredients for an account of the right level of sophistication a simulation has to have for us to say the agent is responding to practical reasons. There's one move from Elizabeth Camp at Rutgers and Ellie Shoup, a PhD student, that I think is quite helpful. There's this 2017 paper they wrote on instrumental reasoning in non-human animals. And one of the moves in that paper is the following. I mean, they're thinking in virtue of what does a simulation encode instrumental reasons? Not every simulation does, so what is required? They argue it's not enough to have purely what they call egocentric models. People mean different things by egocentric. It can get quite confusing. What they mean is that if the model is purely egocentric, there's nothing in it beyond one's own actions and their immediate sensory consequences. And the internal models that guide low-level motor control, like grasping cups, are plausibly quite like this, that they model the immediate consequences of different grip strengths, different movements of the fingers, and probably also the expected sensory feedback that would result from those actions being performed. so that, you know, how it's supposed to feel like when you're holding the cup and it's going well. Camp and Shoup argue that there's got to be more in the simulation than that, and they argue that the extra ingredient needed is there has to be causal and or spatiotemporal relations among features of the environment that are independent of oneself, as in, for example, a causal graph. Also, as in the cognitive maps that Franz de Waal mentioned earlier, that are often posited to be in the hippocampus of the rat, which we'll come back to in a moment. That's one proposal, that to be of the right level of sophistication, the simulations have to have causal and or spatiotemporal relations among features of the environment independent of oneself. I don't think that's quite enough, though. In particular, we've got another question, in virtue of what does a simulation guide the behavior of the whole animal? Because remember, that's a crucial part of what we're looking for here as well. And not just the behavior of a component part or subsystem of the animal. You might think that's another thing that is wrong with those cup grasping models, that it's not just that they don't encode anything independent of the agent, but also that they only control a little part of it, the gripping part. They're not guiding whole animal behavior. That's another attractive thought, I think. One that, you know, on this I'm particularly influenced by Susan Hurley and also Peter Railton, as I'll explain in a moment. So then, in virtue of what does a simulation guide whole agent behavior, there's a quick but wrong answer here, which is to say, maybe the simulation has to be one that represents the whole animal, not just specific parts. Maybe the problem with those low-level models of grasping a cup is that they're just modeling the fingers, they're not modeling the entire body. But I think it's quick but wrong. I don't think representing the whole animal is necessary for a simulation to guide whole animal behavior. My focal example of playing chess is a good example of this. I think that if you think of playing chess like the character in the Queen's Gambit, simulating the consequences of different chess moves, these are all actions that are implemented with a single hand. They're not whole body actions. They're very local actions. Nonetheless, they can still be quintessentially rational actions. So it's really seems like it's not necessary to be representing the whole animal. Not sufficient either, because I think the low-level motor control implemented in the cerebellum will contain at least some models that simulate whole animal movement. I'm thinking in particular of the regulation of balance. That balance is another thing I'm very bad at. But if you think of ballet dancers and gymnasts and people who are extremely good at balance, balance is a whole body activity regulated by inner simulations. But the results of those simulations don't have to register at all in conscious experience. You don't go through life consciously registering those simulations through which you balance. And it sort of leads to the thought that if they don't register experientially at all, they're not encoding reasons for me. They're not supporting rational action. So I think the quick but wrong answer leads to a somewhat better but initially frustrating answer. See what I mean about thinking through these things in real time? But a better answer is that the simulation must be related in the right way to the animal's subjective experience. And that's the sort of line of thought that led me to that conjecture I put on the table at the start of the talk, that there is some deep link between reason-guided action and consciousness. That I think simulations can be enough for reason-guided action, but they must be related in the right way to the animal's subjective experience. It's frustrating because now we've got another problem, which is to explain what it is for these things to be related in the right way. There's then a first thought that I think is, again, quick but wrong, which is to say that, well, maybe what's needed is that the content of the simulation is experienced. What the expert chess players are doing is mentally visualizing a chessboard and simulating consciously what's going on. Maybe that's what's really required. Yes, we do that sometimes, but I think we do it much more rarely than we think. You know, I don't think that that's the default way in which we're guided by reasons. And I think it may well be a relative evolutionary latecomer. I think it's very rare, actually, that we consciously simulate. In fact, one of the lessons of the literature on so-called aphantasia, where people report a total absence of visual mental imagery, is that it doesn't seem to be necessary for sophisticated rational action at all. You can totally lack the ability to consciously simulate imagery, but still be a very good rational agent. So that doesn't seem like the right kind of relation. It doesn't have to be that the content of the simulation is experienced. Perhaps more typically what goes on is that summaries of simulation results are experienced in the form of affect. And that's a thought that Peter Railton has developed, to me quite persuasively, in a series of recent papers, including this one from 2017, that's called At the Core of Our Capacity to Act for a Reason, the Effective System and Evaluative Model-Based Learning and Control. The Railton's hypothesis is that most of the simulation we do is unconscious, almost certainly correct, but that there's a special kind of simulation that guides our actions via affect. That what we experience a lot of the time as affect is the results of unconscious simulations that are evaluating different possible options for action. And that actions that are evaluated positively lead systematically to positive affect, whereas actions evaluated negatively lead systematically to negative affect. So if that's right, then we get something like the following proposal, the following package of sufficient conditions for reason-guided action, summarizing all the moves I've just been through. The first thing that is part of this package is that the animal can evaluate and select prospective courses of action by simulating their consequences. Then we've got this extra condition from Kampf and Shoup that the simulation must model a structured external environment where that structure includes relations among environmental features that are independent of the agent's perspective, go beyond immediate actions and their consequences. And then this third condition that the results of the simulation must register in the animal's subjective experience, not necessarily through conscious visualization, perhaps just through affect, in ways that motivate the courses of action that have been evaluated most positively. If those three conditions are met, the proposal is maybe in those circumstances, even if the animal completely lacks explicit practical reasoning, nonetheless it is responding to practical reasons that are encoded in its internal simulations that meet these three conditions. So in closing, I need to come back to the question of which animals have these abilities. Right, I mentioned Tolman earlier and the rats. Have we ended up with a situation where the level of sophistication we think that is required for reason-guided action is something only hominins possess? No, I think not. And I agree with Railton on this, that a capacity of the type we've just described is very plausibly present in rats, which will simulate and evaluate possible paths through a maze. The rat behavior experts have debated this for about 80 years, but David Reddish in the 2016 paper summarizes that debate and argues that, it's long been observed since Tolman that rats do this behavior sometimes when they're in a maze that looks as though they're weighing up options, because they move their head from side to side, they pause, and then they choose. And then you've got 80 years of debate about whether they are really mentally simulating different options or whether it's a kind of illusion. And Reddish argues, on the basis of sort of neurological investigations of the rat's hippocampus, that it really is very likely there is genuine simulation of the options going on, that you have place cells in the hippocampus representing particular locations in a map of the maze that light up in a way that suggests first the rat is considering one possible path, seeing where that would lead, and then it flips and starts considering the other possible path and starts imagining where that would lead. So Reddish argues that what's called vicarious trial and error, some people think anthropomorphically, really is. There really is literally simulation going on in the rat's brain of the different options. And if it's there in rats, it's not implausible to think it might be common to all mammals. But what about beyond mammals? Well, I think what we can draw from this work on vicarious trial and error in rats is a broader strategy that if we want to find evidence of reason-guided action, let's start by looking for evidence of that vicarious trial and error in maze-type settings. Systematic program of that type hasn't yet occurred, so we can only conjecture what it would show. But this brings me back to the conjecture I put on the table at the beginning, that there's a paper by Malcolm McIver and colleagues that puts forward this idea that vicarious trial and error, even though it hasn't really been looked for in birds or reptiles, may well be common to all amniotes, all mammals, birds, reptiles. Their argument is based on the idea that this is a capacity that is not very advantageous if you lack long-range vision, because the sort of time it takes to evaluate possible courses of action is comparable to the time it takes to actually take them. And if the threat is coming at you from just a few body lengths away, you don't have time. But if you have long-range vision and you can evaluate threats that are hundreds of body lengths away, then it is extremely advantageous to have an ability of the type rats seem to have. So theoretical argument and the empirical evidence to support it doesn't exist yet, but it's a plausible one. If you're then thinking vicarious trial and error is this marker of reason-guided action and one that is associated with long-range vision, I think it's natural to wonder whether it goes beyond even amniotes. You might well start to wonder about even beyond vertebrates. We heard earlier about the salticids studied by Fiona Cross and colleagues in New Zealand, including the famous Portia jumping spiders. These have long-range vision. They have prey that they identify at great distances. They have what seem like very elaborate strategies to pursue those prey. There's ongoing debate about the cognitive mechanisms through which those strategies are implemented. As I read the empirical literature so far, evidence of simulation of the type that exists for rats doesn't quite exist yet for the spiders. I also think evidence of subjective experience, which I've suggested is a necessary condition, is also quite thin for the spiders. But crucially, the fact the evidence is currently thin is not a reason to look. And in fact, I think the sort of program I'm describing here to try and see if we can settle these questions about the deep history of reason-guided action is a program that absolutely should include invertebrates like spiders and also bees, and in general arthropods that face these same challenges of plotting strategies, having seen prey or predators at long distances. Okay, so that's my exploration of the evolution of reasons. Thanks very much for your attention.